Okay, so this is the third video, and we will explore different types of geometry. In the Maya introduction video, there was a short introduction video to two types of geometry: polygons and NURBS. From a historical point of view, the first type of geometry used in 3D computer graphics was implicit description, so a mathematical statement of how a sphere is defined, or cube, or other types of geometries were used to render in very early renderers. So if you look at some of the old stuff done at different labs, you'll see that spheres and planes and generally geometry types are the more typical ones. Then quite quickly polygons were developed, and they of course give you the freedom to create arbitrary shapes. And I guess probably the most well-known model in 3D computer graphics is the Utah teapot, which was created at the Utah University to test out different rendering algorithms, and especially there Jim Blinn is one of the well-known early pioneers in the industry. He developed Blinn shading. So if you are wondering about different material types like Blinn and Fung and Cook Torrance, etc., they're typically named after the people that developed them. So Blinn shading is very popular. Also, Jim Blinn was very big when developing things like texture. So bump mapping, etc., is more or less attributed to him. Polygons is what's called a boundary representation. So if I just create a cube here, you will see that this cube here is actually just a shell, so we can pass through it. It is not a solid piece of geometry, it's just a shell, but we can choose to interpret it as a solid piece of geometry. That is up to us, but it's usually called a boundary representation. Polygon systems vary. Generally today we can draw any type of polygon: triangles, cubes, concave, convex. But what happens once the polygon hits graphics card or renderer is that it is converted to some sort of triangles, or in the case of RenderMan to micro polygons. The other type of polygons here, what you should know is that there's three types of components with these: faces or single polygons, so that's these, and then there's edges or the lines, and then of course the points or the vertices. So this is a vertex. They can be named differently in different applications, but generally we have like a face or a polygon, and then we have an edge, and then we have a vertex or point. That is the level. So like the points or the vertices are the lowest level. Then we have those two or more points are used, or 2 points are used to define an edge, and 3 or more edges are used to define a polygon. Then there is the option of having multiple shells in a polygon object. So this is, at the moment, these are 2 different polygon objects. If I combine these, they are now 1 object, but they have 2 shells. So it's a valid object. It's 2 closed regions, and there's 2 shells. I can select shells in Maya by going to face and then double clicking, and that will extend the selection to that shell. And that is something you will frequently use to select elements. And then of course we have the object again. There is, if I just select this, there, and delete. When you delete object, you need to delete the object. I can't delete the faces. So it will always leave one face if I try to delete a polygon. There will be one face. That's like a definition that any polygon object has at least one polygon or one face. I'll just undo here. If I just select this, and maybe this, and this, then this is still a valid polygon object, but it's open. It's not a closed region. And the usage of like open polygons like these has certain restrictions. So for instance, if we want to use more advanced modeling methods that require closed region like booleans, then this could give us problems. But it is very common to use open polygons. You just have to be aware of the limitations. Polygons can be any shape, as opposed to if we go to NURBS. They are frequently referred to as surfaces in Maya. But so if I choose a NURB sphere, then as we saw in the video, NURBS are typically smooth. They don't have to be smooth. That depends on the degree of the curves. So if we go to this, you can see that the degree of the curves are 3. And that means essentially that it will interpolate across 3 points when generating a curve segment. It also means that we need at least 4 points to generate a curve segment. But NURBS can be made with other degrees. So if I go and say create NURBS primitive sphere, you can see that I can change the degree of the curve. So instead of being cubic, it can be linear. So if I create a linear NURBS, you can see here that the degree is now 1, and that means that I need 2 points to generate a curve segment, and thus a curve is hard-edged. Now, doing this with NURBS is of limited use. You might as well just do it with a polygon, because essentially, well, the big limitation with NURBS is that every piece of NURBS has to be a square. Now you may say, oh, there's a triangle up there, but really this is also a square. There's just 2 points on top of each other up here. All patches or segments of a NURBS is squares. Also, they can't be added together completely unlimited. Every piece of NURBS is a square as well. You can use trimming lines to trim them down to be smaller segments, but essentially that is the limitation, that everything is square. This is also the reason why they are easily interpolated. So NURBS was at some point popular even in the they always been popular in the design industry, where they are used to for modeling cars and industrial design and things like that. There's a very strong tool set for doing things like cutting them into each other and beveling edges and etc. In fact, the NURBS engine by Alias, now Autodesk, that is in Maya, is based on the same NURBS engine that is in something called Auto Studio, where something like 99% of all cars in the world has been through that application in the design stage at some point. So it's very widespread. NURBS was popular in the entertainment industry for a short while. I think the last big movie where NURBS was used was dinosaurs, Disney's dinosaurs. Some tools were developed, I think, specifically for that movie for stitching NURBS patches together. But shortly after that, NURBS was overtaken totally by polygons and the ability to smooth polygons on the run, essentially. So if I create a polygon here, cube, then I can smooth that as a geometry. So if I use the smooth tool here, so essentially I can just smooth this to any level working with it. But lately a more efficient way of working with them has been implemented, both the subdivision surfaces and a smoothed polygon. So if I grab the cube here and I can then press this button number 3, so I switch to a smoothed version. It is still the same polygon, but 1 and 3 will switch back and forth, and I can then work with these points. You can see I'm actually seeing that vertex up here when I grab this point down here. So this is like the projection of that vertex down on the smoothed version, and if I move that, I can deform this sphere that is actually a cube. And this is it differs from program to program, but generally most people are using what's called Catmull-Clark surfaces today. It's a Pixar development at some point, which takes the same sort of mathematics that is used for NURBS and applies them to polygons. And it's a great way of working. You get this nice smooth effect, but you also have the ability to, if you add extra geometry, that will sort of add tension to an area that will then keep the geometry there. So for instance, if I go and grab this edge and I can then use a polygon tool called the Bevel, there. So you can see that actually just takes that one line and splits it into two, and I can then change the offset. If I now press 3 here, you can see that it will help keep this line more tight. So I can like smooth it like this. If I add an extra line there, you can see now I get this sort of thing. So I can smooth it out and tighten it up, and I can just, so you can see this is what we're actually doing, and this is what is getting smoothed, and I can see both of them at the same time by pressing 2. So this is how this works. In Maya there's actually a different way of doing this tightening. This is the most used version, because you get a geometry that you can then edit and do things that will work. For instance, when you're working on this, you can see that here we have a triangle, and generally, like NURBS are all squares, you want to have quarts or 4-sided polygons as much as possible. So if I grab this split polygon tool and then I put a split in here, so you can see that instantly now I have like a 1, 2, 3, 4-sided here. This up here is also 4-sided, so it's all 4-sided, and when I smooth this, you can see that the polygons start to look a little nicer. You can see the flow makes maybe a little more sense than over here. So you have that option. You also have another option in Maya, as mentioned. If I smooth this, then if I grab this, the same edge here, I can use something called creasing. So I have this called the crease tool. If I select that, I can then middle mouse button click and drag, and that will tighten that edge. There we go. So you can see that I'm getting more or less the same effect as before over here. I can use a page up to make this, and page down to make this more or less smooth, like so. So you can see this is the effect here by tightening that. If I grab that and tighten that as well, you can see that this is the effect. So this is also a valid way of modeling, simply using the edges and then using this tighten option to create the shape you like. And this is a very easy way of working. And if we then smooth this on top, you can see how the polygons distribute across this area, and it'll even propagate the tightness of the different edges, etc. So this works very nicely. So these are polygons. Typical ways of working with them is just grabbing a vertex, moving the vertex to deform it. We can grab a face and use the extrude tool. You can grab more faces and use that to create new geometry coming out of that same piece of geometry. So that is a way of generating new geometry, often referred to as box modeling, because people often start with boxes. We can, as we saw, we can bevel edges. So I'm just double clicking to grab the whole edge around and go bevel here. So I'm adding an extra line up here, so you can see that it has to be like close together. If it gets too close, it will merge. So I need to make it like so, and that way we can create like interesting shapes, working our way through this. And also split polygon tool here, so I can go in and split polygons if I like. So I can split these like so. So I'm just clicking. You can see it will try to find the right way, and then click, and then if I want to end it, I right click, and then that sort of applies the split to the polygon. There's a lot of different options in here. Of course, I can smooth it with the smooth tool that will actually subdivide it, so it will just make 4 times as many polygons. So every quad becomes 4 new polygons, every triangle becomes 3 new polygons, etc. And higher level polygons are interpreted as like a mix of quads and triangles, essentially. As you can see, there's a whole bunch of tools here, we'll get back to what some of them does, but this is like the basic thing. Another thing is I can use the extrude as well. See if I just select this and then go shift larger than, I can then grow selection and then press delete. So now I've created an open shell. If I then grab edge and double click the edge, that will extend the edge to the whole border edge. In this case, if I click this one, it will find the edge flowing around using something called edge loop. We'll get back to that. So if I grab this border edge and then use extrude, I'm actually extruding the border edge. So I'm creating, let's see, like this extension of the edge here. So I'll just shift this over to world space. So this way I can change the way it flows off the original edge. I can also change the number of divisions if I like, etc. So that is the basic polygon tools. There are other geometry types. For instance, there are curves that can be used as a basis to create new geometry. So if we draw a series of curves, we can, the classic one is to create the wine bottle. So if I've chosen something called a CV curve tool, I could use an EP curve tool or a Bezier curve tool as well if I like, but I like to use the CV curve. I hold the X key to snap, and I can see there's this dark line here. This is the center. So I will just add a couple of curves here. I'm actually doing something wrong here, but I'll just explain that in a second. So as you can see, I'm building this clockwise, and you will typically want to build this counterclockwise, and I'll show you in a second why that is. Okay, so enter to end. So this is half a cross section of a wine glass. So if I go back to perspective, you can see here, and then I'll use something called a revolve. So I'll go to surfaces, and there's this thing called revolve. If I grab this option box, the little box there on the right, I get this pop-up, and I can choose if I want this to output NURBS or in polygons. It doesn't really matter here because I always change the NURBS to polygons, so I'll just keep it at NURBS. So I'll go revolve around the y-axis. So go revolve, and there we go. I got a glass. If I just delete that, I go back and grab Revolve again. This time I set it to Polygons. And I want this to be control points, that's fine. There you go. So you can see I get a polygon mesh, and I can press 3 to make this nice and smooth. The reason why I said it was wrong to do this clockwise is that every polygon has a front and a back face, and you want the front to point out of it. So if I go to the surface shape here, which is actually geometry, and click on the thing called render stats, there's a checkbox by default on double sided. If I turn that off, oh, okay, so actually this worked for some reason. What I was expecting to see this, which is the curve being inside out. Actually, it was because I built it clockwise on the right side. It had been, if I had built it on the left side, I had been in trouble, I guess. So this is what you don't want. This is what you want. The front face facing out. There is the option here to like turn it on and off, but it will give trouble with more advanced modeling tools, where things will twist or will become inside out. So if you have this being inside out, what you go to is the polygon menu, normals, and then reverse it. Then that will flip the normals the other way around. So yeah, I'll just undo this. Oh, by the way, just to show how the history system works, so if I grab the curve here, there we go, and go to control vertex, you can see I can now edit the curves, and that will affect the shape of the glass I'm working on here. So I can quickly change the shape of this. If I just look at this in front view, I can then work on this and maybe do something. Let's see. Just need to work this out. Maybe I need a few more points, but no, this works okay. I need to move this down a little bit, so something like that. Okay. So I get something that looks like this instead. So that's the advantage of having the history here. Okay, so that was NURBS and polygons, which they play together. I can create a text object which can be either NURBS or polygon output. But the interesting thing is, if I go to dynamics, we have particles, which are just points that can be that can have any shape. So they can be, they're typically spherical, but they can be different shapes, etc. And then we have fluid effects, and the reason why I want to show this is that fluid effects are essentially what's called voxels. So if I create a 3D container, I get this, and this container will have a number of subdivisions. So in this case it has a base resolution of 10, so it'll be 10 by 10 by 10, so 1000 voxels. So each of them are an equally spaced box area, and in there you can have information. So this is a volumetric description of an area, and this is typically used for things like smoke and the different types of fluid effects, because since it's volumetric, it can have a continuous definition of things like pressure and etc. So this can be quite interesting. For the fluid effect, we can actually paint inside it. So we can add it with paint fluid tool, and you can see I get this little plane here, and then I can then start to add content. So just do this for a second, and then I'll show you how this works. I'll just go back here, and then I'll grab my fluid container, go to the attribute editor, and then change the display of this. So oops, I want this to be surface. So you can see this is actually like a solid thing. I just need to change the transparency in this, so it has, there we go. So now it's a solid model. So if I go back to the paint, you can see it'll paint in this ghosting mode. but I can add things and then go here and middle mouse button, drag this to draw at a different point, and then maybe do it like this and then add a little bit down there. So let's see, and then I just drag this to the bottom and then drag a little bit there, go back, and then you can see this is a voxel definition. Now this will actually, this is just the display, so this is also just the boundary representation we're seeing, but actually this box will contain the information of a solid definition. So that is more or less it for geometry, and there are like special types of geometry that are like spheres and cylinders, etc., that are predefined, but they're used for things like fields and light sources, etc. They are not actually geometric models. So this is it for geometry, first of all, and we'll see you back in the second video soon.